Welcome to a special math series built just for school students. No ads, no distractions, just clear, step by step explanations in simple language. In this playlist, we'll discuss everything you need regarding permutation and combination. So let's begin with understanding what is permutation. With the help of three examples, we'll also discuss two notations, one factorial notation and the other one permutation notation itself. So here is a very simple, thoughtful example which says if you have three books, one red, one blue, and one green, how many different ways can you arrange them on a shelf? Think about it, right? Let's say this is the shelf on which you have to arrange the given books. How many different ways can you do it? They are all in a particular order, let's say from left to right, in a straight line. And all are different, right? Red, blue, and green. Well, one way to do it is let's start putting them and see what are the combinations. So let me write down R for red, right? And blue for B for blue and G for green. So that could be one way of doing it as shown here. The next could be we keep the red as such but shuffle blue and green, so that gives us another combination. Now we can think about placing blue first. With that we get two combinations just as we got one and two with red, right? So these are the two combinations which we get with blue. We could also start with green and then again we get two more combinations, correct? So as you can see and count for yourself, we got one, two, three, four, five, six combinations, right? So of course we have six ways of doing it. This is what we call permutations. We say six permutations. So permutations basically is a technical word, right? Which we say is it is defined as how many different ways we can arrange things when order matters, right? So ways of arranging things when order matters. Order really means which book you keep first, right? If you put all of that together, then the order does not matter. All the three are there on the shelf. You get the whole idea. So, order does not matter if, let us say, we are selecting a team of four students from a group of 11. So, any four, it does not matter who was selected first. You get this, right? So, there the order does not matter. But if 11 are running and we are checking who is first, who is second, who is third, in that case, order matters. So, that is the key thing about permutation, right? So, here you will learn a couple of things, and one thing is we had three books and they were all distinct, means you can easily identify each one of them, right? Red book is different from the blue, and blue is different from the green. And we got six different ways, and we saw how the combinations can be made in a straight line to get our solution. Now let's take another case which is very similar to what we dealt with. It is actually for you to do. So you have three cupcakes, very similar to the previous example, and these are chocolate, vanilla, and strawberries. So as soon as you get such examples, you can say C for chocolate, right? B for vanilla, and S for strawberry. And the question is, in how many different ways can you line them up on a tray? Well, it has to be similar, right? So the answer is six ways, correct? And of course, you can make this list, right? And continue. Well, that's simple. But think about this. If I give you six or seven varieties of cupcakes, then it will be a very tedious job to make the whole list. and come out with an answer. You get the whole idea, right? So that means we need a different strategy to get the answer. And this is a common practice. Whenever you have so many distinct items, we should know in how many different ways we are going to arrange them. Perfect. So I will go with the fourth example to explain you how a different way can be adopted. Correct. Now, in this example, I will also give you the notation for permutation. So, the question now is how many four letter words with or without meaning can be formed with letters anil, right? So, if you start with the previous strategy, which we just learned, you will say, well, first will be this, then A, and now I could shift L and I, okay, and I can keep the first two same. Well, now I can change. I can put I first, right? And then N and L, and then A with I can make L and N. Oh, well, there could be many ways as you've just seen. How do we get the right answer faster? That is what we are looking into. Perfect. So, the strategy here is to understand the process which we followed earlier. And the process was that we have four different positions, right? One, two, three, four. We are looking into in how many ways can we fill the first situation, right? In our first example, when we're talking about red, blue, and green, we could put red there, blue there, or green there. And with each, we were left two more positions to fill. And then only one. In this case, what happens? We can now select any one of these four letters. So we have A, N, I, L, four letters in the first position. So we have four choices. So these are number of choices. Great. Once you fix that number, right, or in this case a letter, let's say A, in that case we are left with three others. So for the next position, we have three choices. And once that is fixed, we are left with two choices and then only one choice. So you can see that independently working, we could have those many selections 4, 3, 2, and 1. Now, there is a very beautiful rule which is called the multiplication rule. Now, these choices were independent of one another. Means I could have chosen N instead of A as the first alphabet, right? Or the letter in this particular case to form a word. Okay, great. Then we were left with AIL, and I could choose L as the second letter in my sequence. And then two were left, right? So that is how they are independent, and you could pick up any one of them. And they are distinct because we know A is different from N and N is different from I and L. So multiplication rule says that if these are independent choices one after the other, then total number of ways is just multiply them. Multiply them means 4 times, 3 times, 2 times 1. And that gives you 12 times 2, 24. So there are 24 ways. So you can actually continue with the pattern which we began with. You'll get 24 different words made from these four letters A, N, I, L. They may or may not have meaning. Perfect. We got the answer. So what we see here is that when we had three things, then the answer was 3 times 2 times 1. When we have 4, the answer is 4 times 3 times 2 times 1. So in most of the cases, when we are looking into number of ways, which is permutations, then the answer is that number. So in general, the answer will be what? Let me write it. That number times one less than that number times another one less, that means two less than that number, till we get to just the number 2 and then 1. Do you see that? So always it is being multiplied from all the numbers from 1 to that particular number. So for this, we give a notation which is called factorial notation. And written as n with exclamation mark, n factorial. So we read this as n factorial. It really means multiply all the numbers from 1 to n. So 10 factorial will be 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8 times 9 times 10. That will be 10 factorial. So that is how we get. Another thing which you saw is we had n items and we had to arrange all the n items, which we call permutation, right? So that is also referred to as pnn. Now that is the permutation notation. So in this case we have 4 p4. So we had 4 items in which we had to arrange all the 4, right? So that becomes, so there are a couple of ways to do it. One is this way, the other one is we can write 4 comma 4, right? So from 4 letters, arrange all the 4, right? So general will be PNR, means do not select all of them. Let's say you have 6 letters given. Let's say you take another word which is a slightly bigger word, right? So from that word, choose just 4 letters at a time to make 4 letter words, right? So that could be another type of problem which we are going to do in the next video. But I hope you're getting the variety over here, right? So let's go to the next page where we have written the definitions for you. So as I said, factorial notation, which is very important when we talk about permutations. So now here is the definition for both factorial notation and permutation in clear words. So for every school student, these definitions are very important. Try to make a note of this, right? So factorial notation, as we saw, is to count quickly. So mathematicians use a shortcut called a factorial, right? Which is 3 factorial. So this exclamation mark is meant to be read as factorial. And it really means 3 times 2 times 1, which is 6. So the number of permutations of 3 digits is written as 3 factorial, right? And read as 3 factorial. So that is also number of ways or number of permutations, right? So when we say permutations, we specifically mean distinct items in an order, right? So two things are defined as soon as we say permutations, which is distinct and order. Distinct means you can identify each one of them. They are different from one another, right? So the number of permutations of 3 digits is written as 3 factorial, right? 3 exclamation mark, which is read as 3 factorial. It works like this for any number. If you have 4 items, it's 4 factorial, means 4 times 3 times 2 times 1, which is 24, as the number of ways the letters in anil could be arranged. Permutation of n distinct items is an arrangement of all the items in a defined order. Mathematically, it is denoted by pnn, written as n factorial, or even npr, npn, for all the n items, right? So these are two notations. Next, let's look into factorial notations, their operations, since they are very important in counting number of ways. So now we have understood when we are arranging all the items in a defined order, it's all about permutation, which is written as PNN in brackets or NPN, right? So where is this permutation used and why are we studying it? That's another important thing to understand. So another important question to answer is rather understand why permutations matter. Permutations are used in real life. When you make passwords, then let's say you need 8 combinations. So these are all arrangements. Permutation can help you figure out how many ways can it be done. Schedule a task, which after what. Create seating charts, even model genetic codes in biology. So anytime the order of things matter, you are using permutation. And that's what the thinking should be. Let's continue forward with this introduction to permutations. Now we'll continue with factorial notation, its operations, more examples on permutation, and then combinations. Enjoy the journey of learning. Thank you and all the best.